Assalamualaikum. My name is Mohamad Syahir Bin Nizam from class CEC 22046, and the course is further calculus. And this is my presentation for my assessment 2 for Mat 455. And my group member is Shazana from the same class. So, number one is task 1, double integral and reversing order. So, the first question is plot the region using mathematical application using GeoGebra. So I've made GeoGebra, and how you put the value inside GeoGebra is simple. So this is dx. So just equate it into x to make a calculation, and equate this to x as well to make calculation, and dy just equate this to y to make a formula for GeoGebra. I've pre-made the graphing process prior. So as you can see, x is equals to 4, x is equals to 4 minus y square, y is equals to 2, and y equals to 0. So where is x equals to 4? X equals to 4 is this one, and x equals to 4 minus y square is the curve here, and y is equals to 2 is the red graph here, and then y is equals to 0 is the orange one here. So which part is the our area per se? Our area is this part, and as you can see, my calculation, it's this part. Okay, so that's for plotting the region using mathematical application algebra. Three marks. So the next question is evaluate the given integral. So what I have done is here. So evaluate the integral. As you can see, the limit is the same. So I have integrated using yex and expanded and put in the value. And as you can see, this is the graph. If it's a dx, if it's type uh, if it's type 2, it'll be an dx here. So the graph will be here, and the limit will be x approaching to 4, and y 4 minus y square, and 2 and 0. And if you integrate and solve the problems, you'll get the value 3 over 2 e4 plus half. And then the question said that I need to evaluate the integral by reversing the order of integration. So this is the graph that I presented. It is supposed to be a curve. It is a curve, just for better clarity. And this is a type 1, as you can see. This type 1. And uh, it's an it's the position, it's here's the position. Uh, so the dy is 2, which is here. And then it is the boundary line is 4 minus x, which is here. And then there's the dx, which is 4 and 0. And then you just solve like normal. You integrate and put it in. And I use integration by part to get the same value as above, which is this. Right, so that's for task 1. The next task is task 2, which is triple integral, which is a bit harder. So in this question, draw the projection of diagram using mathematical application algebra from x-axis, y-axis, and z-axis. So my understanding of what the question asks is how if we were to look into in a viewpoint of x, how do we see the graph, and if we see it by the y-axis, what do we see? And the z-axis, yeah, what do we see? So for and obviously, if it's the x-axis, we can see here, and if it's the y-axis, we can see a triangle here. And if it's the z-axis, we definitely can see this. All right. So draw the projection. So I'll show it in the. Again, I have made a 3D version of it. So x equals to y square, which is this part, the curve. Z is equals to 0, which is this part, and z equals to 1 minus x. So the blue line here is the z, the green line here is the y-axis, and the red line here is the x-axis. So let's see the x-axis. The x-axis is here, and you can see a curve here. A curve here, and that's our x-axis view. So now let's see the y-axis. The y-axis is here, and you can see a triangle view here. The z-axis now. The z-axis, let me make it a bit clear. There you are. All right. So the z-axis will look like this. It's more right here. And then the y-axis will look like this, a triangle. And then the x-axis will look like this here. And then you got yourself all of the three sides. So now the next question is find the volume of the integral from each projection. So let's start with x-axis. So as per calculation, the x-axis. The x-axis, as described just now, it looks like this. As the z is in this graph and y is in this graph. Or you can see it here, z-axis, y-axis. So the limit would be 1 and -1 for y-axis, and 1 minus y square, and 0, which is the z-axis. And then I triple integrate to get this, and integrate to get the value of 8 per 15 units cubic. So the next question is the y-axis. So the y-axis, it looks like this, a triangle. The triangle will look like this. So the limit of x would be 1 and 0. Limit of y is 1 and 0 as well. Sorry, 1 minus z, 1 minus z and approaching 0. Right here, 1 minus z, approaching 0. So after we SAZALI and I integrated, the value will give out the same value, which is 8 per 15 units cubic. And the next and final question is from the z-axis of the perspective. The x-axis looks like this. It's here. All right, so the z-axis, the limit of x is 1 and -1, 1 and 1, and y is 1 and y square, 1 and y square. So after we got 1 y square, we just integrate z, which is 1 minus x, and then we integrate it, x squared over 2 plus x, and after we integrate it, the value is the same, which is 8 per 15 unit cubic. So we can conclude that the volume is worth 8 per 15 unit cubic. And that's all from me. Thank you very much. And assalamu alaikum.